Precision Airmotive has a 50-year reputation for quality and skill in radial engine overhaul and repair based on expert workmanship, advanced overhaul equipment, and strict standards of quality control. Precision Airmotive is able to return better than new engines to its customers. We take great pride in our reputation earned through decades of performing safely and dependably under all flying conditions. Precision Airmotive expanded the scope of production operations to include the manufacture and support of aircraft engine carburetors and other accessory components. We're the only source for original, factory-new Bendix pressure carburetor parts and RSA fuel injection systems, formerly Bendix. This video presentation was produced to familiarize you with and ease you into the proper RSA fuel injection system maintenance techniques. Additionally, we'll feature our effective 5-step approach to troubleshooting the RSA fuel metering system. And we'll show you the proper method for executing the engine hot starting procedure. The Precision RSA fuel injection system was originally designed by Bendix in the early 1960s, and surprisingly, very few technicians are familiar with its required maintenance items. It's steadily evolved through the years to the advanced system we know today. The RSA fuel injection technology used in today's aviation fuel injection systems is a state-of-the-art system. Proper preventative system knowledge and maintenance is the easiest way to help keep the system operating to its full engine TBO. Let's start with the fuel servo unit. Maintenance on the fuel servo unit is required at 50-hour intervals. The inlet filter must be inspected and cleaned after the first 25 hours of operation and then at 50-hour intervals. By the way, the filter should be inspected and cleaned at each annual regardless of accumulated hours since the last inspection. Inlet fittings vary from union-type fittings to 90-degree elbows. Be careful. These fittings are specifically modified for the filter assembly. Now, to get at the filter, you need to first remove the inlet fitting. Don't, however, remove the plug opposite the inlet fitting to get at the filter. Doing this allows any contamination that is on the filter to be introduced into the servo unit. Remove the fitting using clean, correctly sized wrenches. Once the fitting is removed, it's easy to remove the filter. Now, if the filter is permanently attached to the inlet fitting, it's not considered a bypassing type and should be replaced. Filter inspection is fairly easy. Checking the outside surface for particulate matter or paring down the middle isn't enough. The fuel flows from the inside out when installed in the servo unit. Contamination, after all, will show up here on the inlet filter long before it can cause any kind of operational problem. Now's the time to catch it by locating and correcting the source of contamination. Dry the filter with air. Now, tap it, open side down, on a clean piece of paper. Examine any contamination and determine the type and source. Next, look into the center of the filter while shining a light through the outside. You should be able to see the light through the weave on most surface areas. You could also blow through the dried filter. There should be very little restriction to airflow. Clean the filter using acetone or MEK, followed by a rinse in Stoddard solvent and then air drying. If the fitting is damaged or corroded, it must be replaced. By the way, corrosion is a fairly good indication that the aircraft fuel system contains a high level of water contamination. Obtaining Precision Airmotive O-rings, and only these specific O-rings, is essential before you begin the filter cleaning process. We recommend you always replace these packings each time the filter is cleaned. Standard AN or MS O-rings might appear identical, but using the wrong O-ring on the inlet fitting has been known to exert sufficient force to crack the servo unit housing. Refer to Service Bulletin RS44. Check the precision part numbers to ensure you're flying with the proper O's. While you're at it, inspect all fuel hoses for signs of deterioration. Teflon lines in most cases should be installed between the servo unit and flow divider, pressurizing valve, or splitters. Refer to the appropriate engine or airframe maintenance manual for specific information. Also, take a look at Lycoming Service Instruction 1274 for additional information on hose application. For filter installation, refer to the appropriate service manual for installation and torque instructions. Cleaning the fuel injection nozzles is next. Hobby's number 9 gun cleaning solvent's the best cleaning solution. A 20 to 30 minute soaking's all that's usually necessary. Then follow with solvent rinse and then air dry prior to inspection. A nozzle is not necessarily clean and satisfactory for use if the cleaning solution no longer changes color. The proper inspection of field inspecting these assemblies is through the use of a 10-power magnifying glass. Both fuel nozzles and fuel restrictors should be shiny clean with no evidence of film or particulate contamination. Only proper inspection can verify a nozzle has been properly cleaned. An increase in indicated fuel flow at various power settings is generally the first indication that nozzles need cleaning. Engine operational problems occur if contamination becomes extreme. Substantial fuel stains around a nozzle also indicate the need for cleaning. And, like the filter, any unusual contaminant should be identified and its source located and corrected. Be sure to refer to Bendix Bulletin RS77 Revision 2 and Lycoming Service Instruction 1414. Do not, under any circumstances, use lock wire, pins, or other metal items to remove contamination from the nozzles. This affects calibration. When cleaning two-piece nozzle assemblies, be sure each restrictor is kept with its respective body. Simply use separate containers for each nozzle assembly. If you're only cleaning the restrictors, which is permitted between annual inspections, work with each cylinder separately by removing, cleaning, inspecting, and reinstalling the restrictor and reconnecting the fuel line. Remember, if you lose a fuel restrictor, you'll have to buy an entire new nozzle body assembly. These restrictors are flow matched to their respective bodies and are only sold as assemblies. Only proper inspection can verify a nozzle has been properly cleaned. The nozzles used with the Precision Air Motive Fuel Injection System have a fuel orifice diameter of approximately 28 thousandths of an inch. As mentioned before, the only proper method of field inspecting these assemblies is through the use of a 10-power magnifying glass. With older style nozzles, check the top threads at the fuel line connection for damaged threads and/or cracks. New and old style nozzles for normally aspirated engines are interchangeable with one another and may be used in any combination on an engine. By the way, standard nozzles flow at 32 pounds per square inch. Now, there are assemblies referred to as high-flow nozzles. The inserts of these high-flow nozzles are identified with a step on their circumference and have a larger diameter to prevent installation into the wrong body. Always refer to the engine manufacturer's publications prior to ordering replacement nozzle assemblies. Now, inspect the nozzle fuel lines before installing your freshly cleaned nozzles. Although these lines are supplied by the engine manufacturer, their condition is critical to the proper operation of the system. Here's what to check. The inside diameter of lines used on most engines should be 85 to 95 thousandths of an inch. If a replacement is needed, do not substitute other lines, like the smaller ID primer lines. A small line on any one cylinder can cause that cylinder to run leaner than the others. By the way, line length is not critical to the operation of the Precision Air Motive system. Check the lines for signs of longitudinal twisting, a sign of over-torqued nuts. Also, inspect for kinks. The minimum bend radius for a line is 62 hundredths of an inch. Check the nuts for cracks. And inspect the ferrule braze joint and surrounding area for cracking. Fuel dye stains are the giveaway. Install the nozzles using a clean 6-point deep well socket. You'll likely have to install your socket over the nozzle first and then attach your extensions and torque wrench. Nozzles are so often damaged by trying to force a socket and extension past engine baffling and over a partially installed nozzle. The baffling is also damaged. Torque nozzles or nozzle bodies to 40 inch-pounds. 60 inch-pounds is the absolute maximum torque to be applied. In a very few instances, your installation might require the alignment of the A. In such cases, increase the torque according to the manual instructions, but don't exceed the maximum torque allowances referred to in the RSA Operations and Service Manual. On nozzles installed horizontally, the A should point down 30 degrees. Remember, if you have the newer two-piece assemblies, check to ensure that the fuel restrictors are properly installed. On engines that have nozzles installed horizontally, leave the shipping cap installed until you connect the fuel line. Improper line connection is a common source of damage. Again, with the two-piece nozzles, failing to follow procedures usually means a new set of nozzles. When installing nozzle fuel lines, make certain all threads are clean. It's first necessary to install the nut finger tight. Now, you have two options. Try to use a torque wrench with adapters if room permits, and torque the nut 25 to 50 inch-pounds. Or, use a standard 7/16 inch open-end wrench and continue to tighten the nut 1/2 to 1 flat of the nut from the finger-tight position and stop. This technique has proven to provide the 25 to 50 inch-pound torque limit. Exceeding the 50 inch-pound torque limit usually does result in nozzle damage. When you've completed the fuel system maintenance, recheck that nothing was overlooked. Pressure test the system for fuel leaks with mixture and idle cutoff. Now you're ready for ground run, minor adjustment of idle speed and mixture if necessary, and return to service. And don't forget your logbook entry. Of course, in all cases, please refer to the proper manual. There's no more effective way of pinpointing a problem or potential problem than locating its source through the process of troubleshooting. And to troubleshoot effectively, one must analyze the problem, its probable causes, and the necessary actions to correct the problem. No wonder troubleshooting is considered an art. Anyone can shotgun an engine's problem, but it's extremely costly for the owner, pilot, and it teaches the technician nothing. Precision Airmotive's suggested troubleshooting procedure for engines, their systems, and components follows 5 basic steps. First, study the symptoms. Secondly, isolate the system affected. Now, determine the probable causes. Then, check and repair the system. And finally, test and document your actions. This segment of our video aids the owner-operator in the troubleshooting technique for the RSA fuel injection system. Of course, read all bulletins carefully before removing a unit for compliance. Take careful note of the section which identifies the units affected by the bulletin and by the part number and serial number if listed. First of all, grab an inspection run-up sheet. You'll find one, which may be copied by the way, on page 2 of Precision Airmotive's Troubleshooting Techniques for the RSA Fuel Metering System Manual, Form 15810B, technically speaking. Note that the inspection run-up sheet is divided into 2 sections, pre- and post-inspection. Remember, the more information you can supply to the factory, the better the factory can help you isolate your problem. Information like parts list numbers, how many total hours since a major overhaul on the servo unit, the engine size and number, and so on are very helpful.
I think there's air in my fuel system. What's going on?
So, you think there might be air in your fuel system? Okay, let's take a look. First, take a 12 to 14 inch length of clear Teflon tubing and connect it between the servo unit fuel line and flow divider. This tubing should be clamped between 2 AN style fittings. Now, start and run your engine and watch for air bubbles. It's very important that you not run your engine, by the way, without the cowling for sustained periods of time, as engine damage might occur. If air bubbles are discovered, locate their source. The primary sources are deteriorated fuel hoses, deteriorated main fuel pump inlet fitting seals. Take a look at Lycoming's Service Bulletin 374 for more information on this one. Airframe boost pump shaft seal leakage, damaged cones and flares on fuel line fittings, and fuel lines routed too close to the exhaust system. By the way, fuel fittings and lines can leak air and not fuel. If having the boost pump on improves operation, then a leaky fitting or hose is possible between the boost pump and the main fuel pump. A large air leak or boost pump shaft seal leak may not give improved operation with the boost pump on.
What is going on? Lately, when I'm in idle cutoff, my engine has a tendency to run on. What gives?
Keep in mind that when your throttle's in idle cutoff position, the manual mixture control on the RSA fuel injector will only reduce fuel flow sufficiently to stop the engine. It is not intended as a fuel shutoff valve. If your engine has the tendency to run on with the mixture in idle cutoff, better check the integrity of the servo unit. First, disconnect the fuel outlet lines from the servo. A flexible hose or clear tube can be attached to direct fuel from an end nozzle into a separate container. A baby bottle's perfect because it's calibrated in cc's. Whatever the container, the measurement process is critical. Now, open the throttle approximately halfway and place the mixture control level in the idle cutoff position. Turn on the boost pump and look for leakage from the outlet. Allow 2 minutes for this test. Hopefully there's no leakage. Great. If there is a leak, measure the amount of captured fuel and divide by 2, or however many minutes you let the boost pump run. This value is the cutoff valve leakage. Now don't be upset if it leaks. Even new units directly from the factory are allowed to leak up to 5 cc's per minute. If leakage exceeds 7 to 8 cc's per minute, dive into Bendix Service Information Letter 16 Revision 2 or later to repair the servo.
My engine at idle sounds like a discontented duck. What do I do to smooth it out?
Though attempting to smooth out the idle speed, off-idle stumble is normally the result of having the following items misadjusted. The idle mixture link was misadjusted too long or too short. The idle speed adjustment was backed out too far, compensating for a possible induction leak. Or the magneto-to-engine timing was advanced from 3 to 5 degrees past the manufacturer's recommendations to smooth out the idle after the first 2 adjustments. Now, to correct the off-idle stumble situation, first, remove the idle mixture link and reset to the proper settings as set forth by the Master Clevis settings for parts lists in the Troubleshooting Techniques Manual, pages 11 through 13. Then, reinstall the idle mixture link. Again, refer to the Master Clevis settings list for exact Clevis settings for a particular parts list control. Of course, referencing this Master Clevis settings list is vital. Next, time the magnetos to the engine. Refer to the engine manufacturer's instructions. Now, start your engine and let it warm up. Then, set the idle speed to the recommended speed. Set the idle mixture to obtain a 25 to 50 RPM rise. Be sure to clear your engine after each adjustment. And now, reset the idle speed as necessary. If off-idle stumble persists, here are some possible causes. There's an intake manifold air leak. Perhaps the manifold drains are sticking open. Or there might be loose pipes or damaged couplings or O-rings. There might be a damaged nozzle or plugged air bleed. Perhaps the magneto internal timing might be wrong or shifted. The flow divider might be sticking open. There might be air in the fuel system. Or the servo unit regulator is contaminated. In that case, send it in for repair. It's important to note that idle speed and mixture adjustments may be made with the boost pump on or off. If there's a noticeable shift in the engine's operation at idle with the boost pump on versus off, your servo unit might need to be returned for correction of pressure sensitivity. Take the time to troubleshoot effectively. You'll save money, time, and headaches. Remember, read all bulletins carefully before removing a unit for compliance. If you're in doubt, call us and ask for help. There are few things more frustrating than trying to start a hot engine, but sooner or later the problem rears its ugly vapor lock in each brand of engine and all makes of airframes to some degree. But take heart. Using the right technique will save you lots of headaches. Let's take a look at the problem. An air-cooled engine starts hot between 15 minutes and 2 hours after shutdown. There are several factors which, when combined, make starting airplane engines, hot or cold, difficult. Aircraft engines are quite simple. They don't have chokes for cold starting, and they don't meter fuel precisely at below idle speeds. Aviation fuel many times fails to vaporize easily at startup. Weak, low RPM spark from magnetos, poor mixture distribution, and updraft carburation are all elements of hot starting. How to alleviate hot starts? Make sure your magnetos are strong, spark plugs are cleaned and properly gapped, and make sure your ignition harness is in good shape. Check your fuel injection system's idle mixture adjustments. There should be a 50 RPM rise as you shut down with the mixture control. Make sure your primer system works properly. Most fuel injection systems don't meter fuel very accurately at low engine speeds. The RSA fuel injection system calls for the priming to provide the majority of the fuel needed for the first few tentative combustion events. Fuel pressure is regulated at the throttle body, which means you can't force extra fuel through the system with the boost pump. And fuel delivery lines sit on top of the engine directly over the cylinder fins. Fuel is simply boiled out of the lines as heat ripples off the just shut down engine. Precision's RSA fuel injection system is a mechanical continuous flow system. Both the throttle and mixture controls should be fully forward for maximum fuel flow. Here's the recommended procedure for the Cessna Cardinal with Lycoming. Throttle open 1/4. Boost pump on. Mixture move from idle cutoff to full rich to obtain a 3 to 5 gallon per hour fuel flow. Then back to idle cutoff. Boost pump off and engage the starter. In theory, the engine will catch within a few revolutions, and you can push the mixture smoothly to a full rich as power develops, then retard the throttle to the desired idle speed. Now, here's a few common sense reminders. Tricks of the hot start trade. Always park in the wind. Open the cowl flaps and even pop open the oil filler door too. In this way, hot air escapes from the top of the cowling and helps to draw cool air up from the outlet area. It's very important to get airflow through the cowling after shutdown. Of course, when you're faced with a hot start, always follow the procedures presented in the operating manual.